Hey guys, how's it going? Today I played with the record keyword, which is really convenient as you don't have to write lots of code and it is really useful, but I wanted to know, is it fast? So I compared it with a normal Java class I wrote, which does more or less the same, and I compared the implementation of the hashCode method, and I wanted to see if is there room for more optimization, or is it really the best thing you can ever get? So let's see the results. You might ask why the performance of hashCode actually is such important that I bother with the implementation. You need to remember that lots of objects that you write will end up in some sort of collection, like an array list, for example, or like a hash set. And whenever you are asking if an object is found inside of that collection, or when trying, for example, to add an object into a collection that does not allow duplicates, like a set, then a comparison with the hashCode will happen. So you need to remember that when you're going through this loop, then you have this hashCode invoked for both objects every time, the one inside of the loop and the one that you try to add or that you try to find in your collection. So you end up with really lots of invocations of the hashCode method of your class, and this is ubiquitous to all applications that you find on Earth. All applications need to use collections somewhere, so the hashCode implementation is really key to optimizing, well, not all, but nearly all applications written in Java, and that's why we look into the hashCode implementation here. The second question is, why are we looking into the hashCode implementation of records? Well, records are really a replacement for lots of classes. If you check your application that you wrote in the past, then you will see that many classes can be replaced by records. So I assume, well, it's really just a guess, but I assume that you can replace, let's say, 10% of your custom classes by records. Everything that you just need to pass data or that you need to store data. Every project, you can replace it with records. So I assume that in future, when you write new code, you will write a lot of records. So records are key for performance because the record code is what makes up, let's say, 10% of your application then. So if you try an hotspot analysis, then you will find that a combination of both, of records and of hashCode, will be one hotspot where you can gain a lot of performance. Okay, so what did I do in this little test? I wrote a small Java program which does two things. First, it does a benchmark with a record, and then it does a benchmark with a class that I programmed in plain old Java, which does more or less the same than the record does. So here you can see the record itself. It has a string along a double and an instant. And here you can see the class, which also has a string along a double and an instant, stores this internally in fields. And let's skip this for the first benchmarks. And I certainly had to implement hashCode. And I want to skip this one for now. I have an equals method. And here we have the benchmark itself. It simply calls hashCode 4 billion times. And this computation simply is needed to prevent optimization in the JVM itself. We don't want that the JVM tries to skip this code just because we don't store the result. So we store the result here by XORing it, and we print it on screen even if we don't need it. Even if we don't need it, just to be sure that there will be no optimization at all. And certainly we have timing here, so we see how long this all needs. So just start with the first benchmarks. The first thing we want to do, or sorry, we have to skip a field or we cannot compile. The first benchmark we want to do is the implementation that records seem to do actually. So this one here. How could I know that? As I said, I tried out several implementations and compared the result numbers, and the result numbers are so more or less the same that I'm pretty sure that this is what actually goes on inside of records. You will see the results and you will accept, even if it's not super perfect timing, no JMH used here, you will see that the numbers are really comparable. So what goes on here in this implementation is that we use the objects.hashCode function, pass each parameter, and inside of that we just do a simple XOR. If we start that, we will see the numbers. Well, it needs a bit of time because to have some really precise numbers, we let run it rather long. It will run on my laptop for at least 10 seconds. So we see here we have the first result. The record needs 11 seconds. And now we will see the result of the class. So this was the record, the original record implementation of the JVM. It needed roughly 11 seconds and my class needed 10 seconds. So we could say that this code is more or less what a record is doing internally. And now let's compare it with other implementations I have written to see if there's a difference. The first alternative implementation I want to try out is this one. It's more or less the same code than the line above. You have to look very in the details if you want to see why it has a different performance. It starts with objects hashcode like the original one. It does XOR like the original one, but then you see here I am using the right classes for the data type of the parameter. So as I do know very well that this is a long, I'm using long hash code instead of objects hash code. I do this with the double, and this is the same code otherwise. So the only change is that I know this is a long and I know this is a double. So why should this be of any different performance? So before I tell you the cause, let's start to have some time to explain it while it's measuring. You must learn that whenever you use a double or a long or an int or whatever, which is of lower case, and you pass it into the object's hashcode method, which accepts an object normally, you can see it here, it wants an object, then the good old auto boxing happens. So from this smaller letter long, you will get created an object of uppercase long. So in the end, you have memory consumption, you have memory cleanup. This all needs time, and this happens for only two variables here, for this long and for this double. And this is so dramatic, even on JDK 17, that you get a difference from 10 seconds, which I had before, the record certainly still is 11 seconds, to just 8.7 seconds. So in my simple benchmarks, I only change 2 places where I prevent boxing, and I gain a benefit of 2 seconds from 10 seconds to 8. So this is really dramatic performance improvement. And I wonder why the JDK doesn't do that internally, actually. I assume that the JDK people expect to optimize this in future. Maybe there is some optimization regarding prevention of boxing or optimizing boxing. I don't know actually. So I just wanted to tell you, you can prevent the boxing if you use the right method from the right class here. So let's go on with the next benchmark. We have this convenient class in the JDK since, let's see, since it doesn't tell us. It doesn't tell us. Since long time. Let's say since long time. And it computes a hash code from multiple parameters. So actually we wouldn't expect that this has a dramatic performance impact. The sole difference is that it has to loop over the parameters, and otherwise it does an XOR, for example. So the loop shouldn't be that slow, shouldn't it? So let's try it out. Let's see if a simple loop compared to hard-coded parameter XORing really has an impact. So we all like to know if this convenience method is the horror or is not. So the record is here, it already is finished in 11 seconds. So let's see how long the class needs. And as you can see, I don't know what to explain. I have no more words to tell you. It needs time and time and time. We're still waiting. There is no result. So the implementation must be absolutely catastrophic. At least in terms of performance, we still have a result yet. So one tip I can tell you right now is don't use objects.hash with multiple parameters if performance is an issue. I still have a result here. Well, maybe we should cut this out of the video to not make it too boring. Let's just see what the result actually is. So finally we have a result of 78 seconds. Wow. Just because we have added a loop instead of hard-coded parameters. So this is what you have to expect from looping instead of hard-coding. So this is something you can consider in other code locations too, if you need optimum performance, then don't go with loops. Apparently hard-coded code runs faster. I'm no expert for the JVM internals or for the CPU internals. I can't tell you why that is, but this is the result. 78 seconds compared to 11 seconds. By the way, you could even store it if it would be a mutable object. In that case, what you need to do is to simply check if you have a stored hash code, and if not, then recompute it. And on the other hand, inside of your setters, simply delete the hash code. So that needs a bit of time too, right? But you still wouldn't recompute with the same values again and again. So today we learned that the record keyword not only is convenient, but also the code is acceptably fast, but there is room for optimization. And now what to do with this information? Well, on one hand, you can decide on your own if record is convenient for you and the performance is good for you, or if you want to stay with normal Java classes, or if you want to write your own optimized implementation of the hashcode interface. Also, I'm playing with the idea of asking the OpenJDK people if I should contribute an optimization for the record keyword, for example, storing the hashcode itself, because records are actually immutable. So let's see what we'll do with that in one of the future episodes. See you, and as always, stay safe and party on!